Welcome back. So next we have an in-conversation session on the subject of everything you need to know about machine learning management, but we're afraid to ask. We're delighted to welcome Craig Martell, head of LyftML at Lyft, to share his wealth of knowledge and provide some top tips. He'll be talking to Chiara Riordan, who's the social media editor at BBC News. Over to you, Chiara.
Thank you for that introduction. We're delighted to be with you all today. I'm with an extremely cool guest, Craig Martell, head of Lyft's machine learning. Now, a lot of you will know Lyft. You probably use their app to travel in a car or a scooter. A massive company. It operates in over 640 cities in the US and Canada. It has actually over 41,000 employees, and it's the second largest ride sharing company, Uber being the first. Now, Craig has a huge amount of experience in the field. He worked for LinkedIn and he worked for Dropbox in the past. He has a PhD in computer science and is also a professor at Northeastern University. Craig, big job you have, big introduction and big job. Can you tell us all what your role involves?
Sure. So let me start by saying that machine learning is done all throughout the company at Lyft. If you think about the Lyft app, almost every part of your interaction with it has some sort of algorithmic machine learning piece to it. My team consists of two large teams. One's called the machine learning platform. Our goal there is to build the infrastructure necessary to quickly build a model, to ship that model, and be able to maintain operational excellence about that model. So, for example, when COVID hit, the world changed. And so any assumptions and the demand changed and the supply changed, and any assumptions that our models might have made about the world probably weren't valid anymore. So we build tools that allow, for example, the ability to quickly retrain, to quickly resample the data, to quickly bring that model back to up to date, given how the world changes. And the world changes all the time. We go in a new city, or new roads are built and demand changes. So we want to be able to very quickly keep our models up to date. The other team that I own is called the Applied ML team. It's a horizontal team. The buzz phrase for it is deep expertise and horizontal impact. The goal of that team is to be on the cutting edge, to know what's going on in industry and in academia, and to figure out how that cutting edge can help Lyft. Now, sometimes that cutting edge is a couple weeks old. Sometimes that cutting edge is 5 years old. But it's our job to figure out. It's this team's job to figure out what algorithms Lyft might not be using that maybe we should be using to get even better. And that team also serves as a consulting wing. If there are engineering teams that need some machine learning help, if there are science teams like the economics team that wants to try a machine learning technique, that team will dive in and help them get it up to speed.
Okay, and from the time that I suppose you studied computer science, have you seen dramatic changes in machine learning?
Yes. So first of all, the irony of modern machine learning is it's the machine learning that people wanted to do in the 70s and the 80s, and there just wasn't enough computational power and there wasn't enough data, because modern machine learning is almost all deep learning. Now, that's not true. There are going to be people in the audience who are going to disagree with me. There's probably some boos, but the vast majority of work that's happening, the new work that's coming out, is deep learning, which is neural nets. And neural nets are a very old technology. What's changed is two things. Video cards turned out to be absolutely amazing at calculating deep nets. And so we've got this remarkable computational power, basically initially driven by the video game industry. But machine learning was able to leverage that power to be able to now analyze and train really deep models, which we couldn't before. And the other thing is, data is now everywhere. Every app that you use, you say you can use my data to build models. That's part of the terms of almost all of those app services, terms of services. And so now we have massive amounts of data and massive amounts of computational power. So that's a really big change starting in the early 2000s. The other big change was about 2013, which was the advent of TensorFlow. So TensorFlow and other frameworks like TensorFlow, TensorFlow was developed by Google, but it essentially abstracted away the hard part. It abstracted away a lot of the having to talk to the machine, having to talk to the metal, and gave a really nice framework for building models that allows many more people to do it, and it allows it to do it in a much larger infrastructure, so that the training of that model, for example, can be distributed across, and a very large N of machines. So, and the side effect of that, algorithmically, is that a lot of the models that I worked on in grad school just don't matter anymore. Like a lot of so for example, my background was natural language processing. In natural language processing, we spent a lot of time thinking about parsing parts of speech, phrases, what's a verb, what's a noun, how do these things go together to give us semantics. And we don't think about those pieces anymore at all. We just, to some degree we do, but on the whole, the theory-laden approaches that we've taken in the past just aren't necessary with deep learning. And that's also going to be controversial. And those people who care about theory-laden approaches are also going to have pitchforks and torches for me. Okay.
Yeah, well, you have experience with all of it, so probably it's good for you and your company to apply all that. So if you have been tasked with setting up an AI or machine learning team in an organization, who do you get on board?
Yeah, that's a great question. I think the first thing you need is the data. So before even doing AI, you have to ask yourself the question, do we have the data? Have we been capturing the data? Have we been storing the data? Is the data readily available? So as a prerequisite to doing machine learning, you need a very strong data engineering team. And so I wouldn't even start thinking about doing machine learning until you've built up a really robust data infrastructure and people who can keep that data fresh and up to date and correct. After that, I would start, given the kinds of tools that are now available, and you don't have to build each algorithm by hand, which you did 20 years ago, 15 years ago even. Given the kinds of tools that are available, I would start with someone who has a very strong scientific background. And why do I say that? Because machine learning is really a fascinating combination of three things: computer science, so the engineering, the software engineering; math, because there's a great deal of mathematical thinking, but also empirical science. Every time you build a model, you're making an assumption, you're making a hypothesis basically about people. You're saying, if I show this top with these pants, more people will buy it. Or if I use this algorithm to match tops and pants, more people will buy both. That's your hypothesis. And it's really a cognitive science hypothesis. You're really saying, this is how people are going to react. And to do that, you need to sample data correctly. You need to do hypothesis testing correctly. You basically need to be an empirical scientist. So one of the first people, you've got to have strong data, and you need an empirical scientist who also is capable of using the machine learning tools. That's how I would start. I would then add a set of what I would call machine learning engineers. Machine learning engineers are software engineers, first and foremost, software engineers. The first side were first and foremost scientists and algorithm developers who could code a little bit. That's gonna, by the way, that'll create a lot of tech debt because they don't code that well. And so you'll hack a lot of things together to get stuff out the door, but that's okay. The next group of people I would hire is machine learning SWEs, so software engineers, people who are primarily software engineers, but who've had enough machine learning. And by the way, almost anybody graduating from college now in computer science has had enough machine learning classes because it's really popular. So they would have had enough machine learning to understand the process that the scientist was going through and to be able to support that, from an engineering perspective. And then ideally what you really want is the unicorn, which are both of those, a group of people that are basically both of those in one body. And those are really hard. Those are folks like who have a PhD in computer science, specializing in machine learning. And you want those folks, eventually, you want those folks because there'll be some algorithms that are really sophisticated, so the scientists could think about those, But when you implement them, they change the algorithm. So you're going to have some problems where you really need to understand the interplay between the infrastructure and the algorithm. And so note in my initial story, we had a scientist, and then we had software engineers. Neither could do that in between. So eventually, you're going to need someone who's really good at bridging that gap. And those folks usually look like either a lot of experience in industry or a PhD in machine learning. Those are the hardest ones to find. And I wouldn't wait for those folks to get started, because you have enough tools and frameworks now that you don't need to wait for them to get started.
Okay, brilliant. Your line went slightly a bit bad, but I think you summed it up towards the end anyway. So data scientists, software engineers, and then PhD students in machine learning. I listened to one of your interviews, and if somebody was given a team, to manage, like they're a manager in machine learning, you said something very good. You said that take a course or try and get well up in it, because you're managing a team and you need to understand what's going on.
Yeah. So people don't want to hear this. This is often a difficult thing to hear, but if you're going to manage a machine learning team, it's not like generic software engineering management. The life cycle is different. What they're capable of doing is different. How long it takes to get a model built is different. So it's not a sequence of 2-week sprints, which is what most software engineering managers would be used to, how they'd be used to thinking. It might take a whole quarter to gather your data. It might take another whole quarter to build your first model, and it won't be very good. It'll be just barely better than random. And then it'll be another whole quarter before you iterate on that model and get to a point where you think it's going to have a large impact on your business. So the life cycle is very different. I liken it to the following. You wouldn't ask a product manager to go manage a bunch of software engineers, right? You need an engineering manager, because you need someone who understands how software engineers work. I think it's similar. Generic software engineering isn't going to be enough to cover what the machine learning team is going to build. So I think you can start by being an engineering manager. I think that's great. I think you need to take a class on how machine learning works. You can do that online. There's a lot of great stuff online. Andrew Ng's stuff is phenomenal. Some of the best stuff I've ever seen. But you can also just go to a local college, take it pass fail, because the grade doesn't matter. But what you really want to get is, how do I think like a machine learning engineer? How do I think like a machine learner? And the reason you need to do that, in part, well, one, you need to talk to your team, but you also want to represent your team well up. You want to be able to say to your boss, hey, this is what my team can do. And you can't represent them if you don't know how they work. So I strongly believe that you have to go you need to get some machine learning skills yourself.
Yeah, I think that's a really good point. So everyone will be dying to know about Lyft and self-driving cars. So can you tell us, where it's where it's at and what's the strategy?
So no, for 2 reasons. One, if I knew a bunch, I probably couldn't tell you what it is. And secondly, I don't know a bunch, because the L5, level 5, is a separate business unit. And the work that I'm working on is about the rideshare division. So how do we get you cars? Who's your driver? How do we estimate how long it'll take? How do we do paying? Those sorts of things. My team's not actually working on the self-driving cars. Now, were I to know anything about what we're gonna do with self-driving cars, I'm pretty sure I couldn't share it anyway. So I'm just gonna say no.
At least I tried.
You did, yeah. And I find self-driving cars really fascinating. I will say this personally, I'm not speaking for Lyft, I'm still a little scared by them.
Yeah, I think,
right? If you do get it wrong, the consequences are high. But I also know the folks down there, they're super smart, and I also know that they're super cautious. So I don't think we're gonna do anything dangerous.
Yeah, no, that's okay. Well, thank you for answering the question.
Or not answering the question is the question.
Yeah, but being really polite about it though. In terms of, there's 2 questions I have. One, I want to get to it before we've 4 minutes left. Unconscious bias in machine learning. I mean, a lot of that's going to be discussed throughout today anyway. How have you seen it in force in your current job, in your past jobs, and how do you solve it?
Yeah, so let's. I know in 4 minutes this is a really important topic, and we shouldn't give it short shrift. But I will say this: let's ask this: where does unconscious bias, where does the bias come from? The bias comes from the data set, right? Because machine learning is taking a data set and trying to model that data set and use it to predict the future. And if the data that you get is biased, then you're going to build a model that's biased. That's just going to be mathematically the case, right? So what you have to focus on making sure your data is not biased. Now, what does that mean? That often means making choices. That means that, like, if I go gather data in the world and the world's biased in a certain way, my data is going to be biased. So I need to make sure that I'm sampling in a way that I want the world to be sometimes, not just the way the world is. So if, for example, I'm trying to predict something about our drivers, and our drivers are skewed and there's only a small population of a certain type, Irish women with red tops. Maybe there's just a small population of those. Well, I don't want to just sample the world as it is. I want to go find more like that so that I can make sure I'm giving you the right weight in the model, right? So you really have to understand how the world's distributed. You have to sample in a way that you want the world to be. And I think here's the most important part. So that's just mathematical. So we can figure all that out. I think the way to guarantee before you ship it out the door that you did a good job is to have a more diverse workforce. So if you have people that represent your customer base, and we don't all look the same, and we come from wide backgrounds, then those people can look at the model before it ships and say, how does this impact me? So we did this at Dropbox for image search, where we wanted to make sure that nothing about our image search created discomfort for anybody. So we asked the employee research groups to do image searches over and over and over again. And when they found problems, we resampled, we gathered new data to solve those problems. So I really think it's a twofold solution. One is making sure you sample the world the way you want it to be. Secondly, verify that you sampled the world the way you want it to be by having a diverse workforce to bang on that. I call that adversarial testing, to bang on that before it ships. Did I get that in under minutes?
Yeah, and you know, people would say, oh, it's kind of male skewed, as in people who work in data science and engineering and stuff. But you're saying that the entire organization can get involved.
Yeah, it doesn't have. That's right. So let's set aside the harder problem of why there's a male skew in data science and computer science. That's a fascinating and difficult problem that we should be working to solve. But that's a longer term problem or a harder problem to solve. We can solve this one more quickly by just taking the diverse workforce around the company and say, hey, could you try this for us? Is there anything about this model that causes danger or concern for you? And let them use the model, because I'm probably not going to think about certain things, right? My background is going to prevent me from thinking about certain potential dangers, but someone else's background will allow them to do that. So we want as many eyes on the model as possible, trying to find problems. You should be trying to find problems. That's the adversarial testing part. And we should use the whole company for that.
Yeah, brilliant. So we have to finish, sadly. Craig, thank you so much for joining us today. It was brilliant, such great insight into the area and your expertise. So thank you very much.
I really enjoyed it. Thank you.
That's brilliant. And thank you to everybody for watching as well. And I'm going to hand back over to the chair.
Thank you so much, Craig and Chiara. Some fantastic advice there, particularly if you're looking to hire anyone technical, but also to understand the mindset of how you're going to tackle some of those machine learning problems for your business.